What if everything we thought we knew about the early universe was wrong? For decades, astronomers have built their models on limited glimpses of distant galaxies, relying on Hubble and other telescopes to piece together a story that seemed complete. But now, the James Webb Space Telescope is rewriting that story in ways no one expected. With its unprecedented ability to peer through the cosmic dark ages, Webb is revealing galaxies that shouldn't exist yet. Black holes forming far earlier than theories predicted, and streams of light escaping hydrogen clouds thought to be impenetrable. Each new image challenges our understanding of cosmic evolution, forcing scientists to ask questions that have no easy answers. Are we seeing a universe older than we imagined, or evidence of something far stranger, a hidden chapter in the cosmos waiting to be uncovered? What Webb has captured is more than distant light. It's a window into a universe that may be far more complex, mysterious, and astonishing than humanity has ever dared to imagine. When the James Webb Space Telescope began sending back its first images, the scientific community braced for confirmation of what we already thought we knew about the early universe. Instead, Webb delivered surprises that challenged decades of assumptions. Among the earliest revelations were galaxies shining brightly in periods once considered shrouded in darkness, a time astronomers call the Dark Ages. During this epoch, the universe was filled with dense clouds of hydrogen gas, and the formation of stars and galaxies was thought to be slow and hidden. Yet Webb's instruments revealed streams of Lyman alpha light piercing through these clouds, signaling that galaxies were merging, forming stars and creating channels of ionized hydrogen far earlier than expected. These emissions, once presumed blocked, showed that the first generations of stars were already powerful enough to carve paths through the opaque cosmic fog, illuminating their surroundings and reshaping our understanding of how structure emerged in the infant universe. What was previously assumed to be a simple, slow process of cosmic evolution now appeared far more dynamic, with galaxies interacting, merging, and accelerating their growth in ways that standard models had not predicted. This realization forced scientists to reconsider the timeline of galaxy formation, acknowledging that the universe's earliest chapters were far more active and complex than we had ever imagined, and opening new questions about the processes that governed these extraordinary early formations. Among Webb's most astonishing discoveries were galaxies so distant that their light has traveled over 13 billion years to reach us, revealing structures from the universe's earliest moments. Two galaxies in particular stood out, highly redshifted, distinct from anything seen before, and seemingly existing well beyond the traditional Dark Ages. These objects defied expectations, suggesting that massive galactic structures formed far sooner than conventional models predicted. Spectroscopic observations, still underway, promise to confirm just how ancient these galaxies are, potentially rewriting our understanding of cosmic history. Their brightness, size, and activity hint at rapid star formation and mergers occurring mere hundreds of millions of years after the Big Bang. Such findings raise fundamental questions. Is the universe older than we thought? Did some unknown process accelerate the birth of these early galaxies? Or are we witnessing remnants of events from before our universe's known beginning? Each discovery peels back another layer of the cosmos, forcing astronomers to confront scenarios that stretch the imagination, from accelerated formation mechanisms to the possibility of influences from prior cosmic cycles. Webb has not merely extended our reach, it has shattered the boundaries of expectation, showing that the first moments of the universe were alive with activity that our models had not anticipated. One of the most striking revelations from Webb's observations is the existence of supermassive black holes forming astonishingly early in the universe. Galaxies like GN-ZD 11, located over 13 billion light-years away, host black holes whose mass challenges our understanding of cosmic timelines. Conventional theories suggest that black holes of this magnitude require multiple generations of stars and mergers to form. Yet here they are, fully grown in a universe still in its infancy. These discoveries force astronomers to reconsider the mechanisms of black hole formation, suggesting that either unknown processes accelerated their growth or that entirely new models are needed. The implications extend beyond individual galaxies. They reshape our grasp of early cosmic structure, galaxy evolution, and the dynamics of the primordial universe. As researchers continue to analyze the data, Webb's revelations hint that the early cosmos was far more complex and energetic than previously imagined, filled with rapidly evolving systems that challenge long-standing assumptions and open the door to entirely new theories about how the universe developed in its first few 100 million years. Webb's deep-field images have also uncovered galaxies that existed well beyond the so-called Dark Ages, a period long thought to be shrouded in impenetrable hydrogen clouds. Previously, astronomers believed that the earliest galaxies could not shine through this dense fog, making their detection nearly impossible. Yet Webb has revealed brilliant sources of Lyman alpha emission, indicating that stars in these primordial galaxies were forming bubbles and channels of ionized hydrogen that allowed light to escape. This unexpected clarity exposes a universe far more dynamic than anticipated, where star formation, galactic mergers, and energetic interactions were occurring at a pace that defies prior models. Each discovery of these distant galaxies challenges the timeline of cosmic evolution, suggesting that the processes shaping the early universe happened faster and more efficiently than our theories had predicted. The presence of these luminous, highly redshifted galaxies raises fundamental questions about the age of the universe, the formation of the first stars, and the mechanisms driving early galaxy growth, forcing astronomers to rethink the narrative of the universe's first billion years. Among the most astonishing revelations from Webb is the discovery of supermassive black holes forming in the earliest epochs of the universe. One galaxy, GNZ11, located roughly 13.2 billion light-years away, harbors a black hole so massive that its very existence challenges our understanding of cosmic timelines. Traditional models suggest that black holes of this scale could not have formed so quickly after the Big Bang, as the processes of star death and black hole mergers would require far more time. Yet Webb's observations confirm that these colossal objects were already present, forcing astronomers to consider alternative mechanisms for rapid black hole growth. Some speculate that early galactic collisions accelerated mass accumulation, while others propose entirely new physics that could allow such extreme structures to emerge within the universe's infancy. Beyond GNZ11, Webb has identified additional distant galaxies with similar anomalies, each harboring unexpectedly massive black holes. These findings not only challenge our models of black hole formation, but also hint at a universe far more active and structurally complex during its earliest stages than previously imagined. The presence of these giants reshapes our understanding of cosmic evolution, revealing that the universe's formative years were marked by processes we are only beginning to comprehend. Webb's revelations extend beyond supermassive black holes, uncovering galaxies that existed well before what we once thought was possible. Two recently observed galaxies, located at a redshift of around 16, shine brightly despite existing in an era previously considered the cosmic dark ages. Standard cosmological models predicted that galaxies would only form after these dark clouds of neutral hydrogen cleared. Yet here we see massive, structured galaxies thriving in the primordial universe. This challenges the assumption that early cosmic evolution was slow and gradual, suggesting instead that the universe may have undergone periods of rapid development or that unknown processes accelerated galaxy formation. Some scientists have turned to alternative models, like conformal cyclic cosmology, which proposes that energy from evaporating black holes in a prior universe could have jump-started the formation of these early structures. Regardless of the explanation, these discoveries demand a complete re-evaluation of how and when the first galaxies emerged, indicating that the universe's early history was far more dynamic and complex than previously believed. The discoveries from Webb also force us to reconsider the timeline and mechanisms of cosmic structure formation. Beyond merely existing earlier than expected, these ancient galaxies exhibit surprising levels of organization, with dense clusters, interactions, and vigorous star formation occurring far sooner than models predicted. Observations suggest that galactic mergers were already shaping the universe, creating bubbles of ionized hydrogen that allowed light to escape even during periods once thought opaque. This indicates that the processes driving galaxy evolution, gravitational interactions, star formation, and black hole growth were operating at unprecedented speed, reshaping our understanding of how matter assembled in the early cosmos. Each new image and dataset not only provides evidence of these phenomena but also raises profound questions. Were these processes driven by unknown physical mechanisms, or do they point to an entirely different cosmic history than the one we have long assumed? Webb's observations are rewriting the story of the universe's infancy, revealing a cosmos that matured faster, more energetically, and far more surprisingly than anyone anticipated. Perhaps the most astonishing revelations come from the very edge of the observable universe, where Webb peers back to the cosmic dawn, only a few 100 million years after the Big Bang. Here, galaxies shine with unexpected brightness and complexity, defying the conventional timeline of cosmic evolution. These early structures contain surprisingly heavy elements, evidence that entire generations of stars lived and died even before the universe reached its first billion years. Such findings challenge the standard models, implying that star formation, black hole growth, and galactic assembly occurred far more rapidly than previously believed. Each discovery forces astronomers to ask new questions. How did these massive galaxies form so quickly, and what unknown forces might have accelerated their evolution? Webb is revealing a universe that is not only larger and older than expected, but far more active and intricate, hinting at processes and histories that remain almost entirely hidden from our prior understanding. Perhaps the most astonishing revelations come from the very edge of the observable universe, where Webb peers back to the cosmic dawn, only a few 100 million years after the Big Bang. Here, galaxies shine with unexpected brightness and complexity, defying the conventional timeline of cosmic evolution. These early structures contain surprisingly heavy elements, evidence that entire generations of stars lived and died even before the universe reached its first billion years. Such findings challenge the standard models, implying that star formation, black hole growth, and galactic assembly occurred far more rapidly than previously believed. Each discovery forces astronomers to ask new questions. How did these massive galaxies form so quickly, and what unknown forces might have accelerated their evolution? Webb is revealing a universe that is not only larger and older than expected, but far more active and intricate, hinting at processes and histories that remain almost entirely hidden from our prior understanding.